Students, we were discussing one sum. Okay, this sum I've just written it the equations. I'll just repeat it once again for you all. Okay, the amplitude of a wave disturbance propagating in the positive x direction is given by this equation, that is y equals to 1 by 1 plus x square at time t equals to 0. Okay, and by y equals to this equation at time equals to 2 seconds. Okay, and both the x and y are in meters. Okay, now the shape of the wave disturbance does not change during the propagation. This is the information given. And what is the velocity of the wave? This you have to find it out. Okay, now students, what will I do that all these two equations are given. That means y's value is given, that means the displacement's value is given in terms of x. Okay, now what will I do, students? I will find out the values of x in terms of y. Okay, and I will terms those x value as x1 and x2. Understood? I'm just repeating this once again. These values of y's are given in terms of x. Now what will I do? I will find out the value of x in terms of y. Okay, that means only have to arrange it mathematically. Okay, and I will term those x as x1 and x2. x1 for this and x2 for this. Alright, so let's start this up. So I'm terming this particular equation considering this equation, students. So I will term x as x1. x1 will be equal to, this mathematical part I'm not teaching because this we have learned how to arrange it, will be equal to 1 by y minus 1. Alright, so that was your at time equals to 0 second. Okay, I'm writing here time equals to 0 second. Now I will find out this equation, that means I will find out x2 in terms of y, isn't it? So what will I write? I'm writing here x2 will be what? Root 1 by y minus 1 plus 1. Okay, just arrange it mathematically. Okay. Now students, if the velocity of the wave be v, small v, then what is the basic concept of the velocity? Basic concept of velocity is that total distance by total time or change of distance with respect to change in time, isn't it? So I'm writing here because what is your question? Your question is what is the velocity of the wave? So your v will be x2 minus x1 by t2 minus t1. Change of distance x2 minus x1, this is your change of distance, and change of time means t2 minus t1. Yes, I can write it. Why I have chosen this formula, students? Because t2 minus t1 you can able to get from the question because details are given. Alright, so I can write as, in this part I am writing, students, as t2 minus t1 is what? 2 minus 0 is your 2 second. So yes, my denominator part I am getting from here, from the question, and the numerator part that is your x2 minus x1, this also I will get from these equations, these two equations of that I've written on top, x2 minus x1 c. So yes, so let us write. So x2's values is this, minus this I'm putting in bracket, okay, so that you don't make mistake. And x1's values is this, x1, alright. and this divided by T2 minus T1's values I have written, that is your 2. Okay. So now just do the calculation, students. Okay. We will left, yes. See, this and this will get cancelled. Root 1 by y minus 1. Here also we are getting root 1 by y minus 1. This 1 is also under the root. Okay. So both the terms will get cancelled and you will be left with only 1 by 2. So 1 by 2 means what? 0.5 meter per second. Isn't it? Repeating the solution in a very short for the last time. I have just written the y's values was given, and what I have done, I have calculated the values of x in terms of y. Both the values of x, that is x1 and x2. Alright. Why I have done this? Because I have to find out the velocity of the wave. What is the basic concept of this velocity? Change of distance with respect to change in time. So change in time I can able to get because data are given in the question. 2 minus 0 is 2, that is t2 minus t1. So I have written it in the denominator, and x2 minus x1 as well is also I am getting from these two equations that I have written here. Alright, so yes, my sum is done. Okay, very important question and very easy. Alright. Okay. Now students, I will discuss sums now from your section. See, section is the same, the wave section, but from this beats part, isn't it? I think in your book it's given under the chapter stationary wave. Okay, you can yes, you can also superposition of waves, I think you can also check it out. But okay, but we will right now we will discuss the sums regarding the beats. Alright, the beats we have done it in the classes, the theory. Now we will see some sums from this part. Alright, let's do a small sum. A tuning fork, this is a question I'm dictating. A tuning fork originally in unison with another tuning fork of frequency 512 produces 5 beats per second. Okay. Part A, when a little wax is attached to it. Part B, when it is filled. Understood? See the situation. First part, when there is little wax attached to the tuning fork, and your